our next concept is programming language basic. So any programming language we are taking as the input, then converting into other form using compiler. So some basic fundamentals we need to study. So the outline of this lecture consisting of, first we will discuss about static and dynamic distinction, then environments and states, then static scope and block structures, then explicit access control, then dynamic scope, then parameter passing mechanisms, then aliasing. So all these concepts, whenever you are studying programming languages, these concepts, so we may aware. So now here briefly we will review all these programming language basic concepts. So here, to design an efficient compiler, we should know some language basics, whatever the outline we mentioned. The first basic is the static or dynamic distinction. Second one is environments and states. Third one is static scope and block structure. Fourth one is explicit access control. Fifth one is dynamic scope. Then sixth one is parameter passing mechanisms. Then last one is aliasing. We will review all these basic concepts one by one. So then coming to the first one, the static and dynamic distinction. So how these two are varied? What are the differences? So static is nothing but we know events occur at compile time. That is called a static environment. Whereas dynamic or dynamic environment, which should occur, an event occur at runtime or execution time. This is the major difference between static and dynamic. Let us see one example. The scope of declaration of a variable x is the region of the program in which uses of x refer to this declaration. A language uses static scope, also called as lexical scope. If it is possible to determine the scope of a declaration by looking only at the program, by seeing only the program. So otherwise, the language uses dynamic scope. Dynamic scope also called as execution, that is runtime or execution time. Whereas static scope or lexical scope only at compile time. This can be done by seeing the declaration only at the program level. Otherwise, the language uses dynamic scope, which can be occurred at runtime or execution time. With dynamic scope, as the program runs, the same use of x could refer to any of several different declarations of x during runtime or execution time. Whereas the static scope or lexical scope only by seeing the program, the scope will be used. So that is the static and dynamic distinctions. So then coming to environments and states. So the environment is mapping from names to locations in the storage. So which can be mapped from names to the locations in the store or storage area. Since variables refers to locations, we could alternatively define an environment as a mapping from names to variables simply. The state is a mapping from locations in a store to their values. So mapping from locations where they store and to their values, that is called as the state. Now let us see the following diagram, which shows two-state mapping from names to values. This can be taken from our prescribed book Aho with second edition. So now here you can see map two-state to our two-stage mapping from names to values. Here you can see first we have names, then right hand side we have values. So via location means by using variables. So first part mapping from the first stage is names to locations with the variables is called as environment stage. Then the second stage from variables means their locations to values, that is called as state. So this is called as environment and state representation. So mapping from names to values through their locations by using variables. So this is called as environments and states. Then let us move to our next basic concept, static scope and block structure. So in many programming languages, this concept is very important. The scope rules for C language, let us say, are based on program structure. The scope of a declaration, is determined implicitly within that program, within that method, by where the declaration appears in the program. Then programming languages like C++, Java, and C# also provide explicit control over scopes through the use of keywords like public, private, and protected. So here, explicit control is allowed. So whereas in C language, like here only implicit control or access is allowed. So a block is a grouping of declarations. That means some set of declarations and statements. That is nothing but a block. C language uses braces like open brace and closed brace. Then to delimit a block, that means ends the block. The alternate use of begin and end in some languages. For example, in any C language, you can take here open brace, closed brace. Here set of declarations followed by statements. This is called as one block. Then some programming language uses begin, end. So here set of declarations and statements. This is also called as block. So based on programming languages, so this representation is different. That is called as block. Then if you want to use a block further, that can be called or a static scope. That means that can be defined during compile time only. So whereas dynamic scope, that is for runtime. Let us see one example. So here, this is the one example C++ program is taken. Here we have main function with braces, then delimiter. So this is open. Then here at the end delimiter is there. So now here you can see here we have two declarations like int a equal to 1, int b equal to 1. So then at the end you can here open its function, then end, then cout means you have to print a and b. So this outer view can be treated as block 1. This is block b1. So now inside you can see inside the method we have another declaration int b equal to 2. So this is a different value. Earlier we have b equal to 1. Now another declaration with same b equal to 2, different value. Here again another declaration inside this int a equal to 3. Then cout a b. Now you are printing a and b. So now this one we'll call it as block 2. Now this part we will call it as block 3. So then here this declaration is closed. Then again you have to open the next one into b equal to 4. Then cout ab. This is another block. So now we can see main block is b1. Inside b1 here we have b2. Inside b2 we have b3 and b4. So the inside blocks we will call it as nested blocks, like nested if then else. So like that some set of declaration of statements will be grouped into one block. Then based on their static scope and block structure, those can be called based on the dependent variables. So this is the example of blocks and static scope. So now here you can see here based on the declarations, now we can define the scope values. So now that means whatever the declaration variable, so that will be occurred in which blocks, the scope where that will be used. For example, first int a equal to 1. You declared a as 1. Now here the scope is from block b1 to b3. Now here you can see int a equal to 1, but because this is the main block, this is main block. So here inside the main block, here block B2, here block B2 uses A, printing A. Then in block B3 also, here it uses A equal to 3. So the scope is, so where the variable A is called, why? Because B1 is the main block. So in B1 itself, then B2, then B3. So B1 to B3, that is the scope. Similarly, into B equal to 1. So into B equal to 1, that is declared in B1 block. Then in B2 block also, B is called, but with a different value. But scope is there, same variable name. So here B1 to B2. So then into B equal to 2, here you can see the value 2. The scope of B equal to 2. So blocks B2 to B4. So now here block B2, here 2 is used. So then within this, here you are printing B, then B is called here. So then in B4 also B is declared. So now because B4 is the nested one of B2, so compulsory it takes the B equal to 2 declaration also. Then it prints so B2 to B4. Like that you can define the scope. Similarly for int A equal to 3. See, A equal to 3 occurred only in this block, separately B3 we have. So the scope is B3. Then into B equal to 4, the last one, into B equal to 4 declared in only B4 block. The scope is only this one. So others, why we have taken means B4, B3 nested of B2 or B2 is nested of B1. That's why those can be inherited. Like that we have to take the scopes. So then coming to explicit access control. So previously the static one is nothing but implicit. Now explicit access control. So by using C++, Java, etc. languages, by using some keywords, public, private, protected, the explicit access control can be done. So here classes and structures introduce a new scope for their members. If P is an object of a class with a field X, which is called as a member, then the use of X in P can be referred as P.X using dot operator. That means calls. So X is derived from the object P. So refers to field X in the class definition. Through the use of keywords like public, private, and protected, and object-oriented languages such as C++ or Java provide explicit control over access to member names in a superclass. So we know the object-oriented programming concepts like class, object, inheritance. So these keywords support encapsulation by restricting access. Encapsulation, data hiding. So the first keyword is public. Public names are accessible from outside of the class also. Whereas private names include method declarations and definitions associated with that class and any friend classes only within that restricted areas. Whereas protected names are accessible to only subclasses. So these are all the three important keywords used in object-oriented programming languages like C++ and Java. So to allow explicit access control. So then coming to dynamic scope. Dynamic means during runtime or execution time. So the term dynamic scope, however, usually refers to the following policy. A use of a name X refers to the declaration of X in the most recently called procedure with such a declaration. Suppose X is declared several times, but it uses only recent declaration of that X. So that means recent execution. Then dynamic scoping of this type appears only in special situations. So there are two dynamic scope policies are there. First one, macro expansion in C preprocessors, then method resolution in object-oriented programming like C++ or Java. So here it uses method resolution in object-oriented programming, whereas in C preprocessor uses macro expansion using some hash. prefixed with hash. So this is the dynamic scope. Now let us see one example. Since dynamic scoping is very uncommon, so in the familiar languages, we consider the following code as our example. The sample code, int x equal to 10, called by G function. Then you are defining a function f, which returns the value of x. Then G has its own variable named as x and calls f. Then the G function defined as int G, here x equal to 20 is declared, then it returns f value, calls from the above function. Then the main function is, here it print f of g of. So first it calls G function, then it takes f of that function value. So now here, whenever you can run this program, after running this program, here you will get output as 20. If you want, you can practice this program using our C language. So here, dynamic scoping means here it uses the recent declaration we already mentioned. Here x equal to 10, actually initially x is declared as 10, but recent value of x is in G is x equal to 20. So here return f means here it displays the value as 20 is the output. So what we mentioned, the dynamic scoping, recent value, recent declared value will be used. So that is the dynamic scope. So then coming to parameter passing mechanisms. So this is also very important concept in any programming languages. So every language has some methods for passing parameters to functions and procedures. Formal parameters, actual parameters. We have two types. So in formal parameters, the identifier used in a method to stand for the value that is passed into the method by a caller, the formal parameters. Whereas actual parameters, the actual value that is passed into the method by a caller. So the actual parameters are classified into three types. The first one is call by value, second one is call by reference, third one is call by name. So call by value, the actual parameter is evaluated if it is an expression, or copied if it is a variable in a formal parameter. Call by value, only the actual parameter is evaluated. Whereas call by reference, address is used. The address of the actual parameter is passed as value of the corresponding formal parameter. Then call by name, the called object execute as if the actual parameter were substituted literally for the formal parameter by using the substituted value, that is name. So these are all the three actual types of parameter passing mechanisms, which are comes under actual parameters, that is call by value, call by reference, call by name. Now let us see one example here, parameter passing mechanism. This is taken from the reference, the link is given here. So one of the tutorial, here you can see the first box shows call by value, second box shows call by reference, third box shows call by name. Here you can see these are all the sample codes written in C language. Here as include stdio.h, here int sum, the parameters or int a comma b. So these are all called as formal parameters. Then in main function, here we declared two variables, variable 1 equal to 10, variable 2 equal to 20. So these are all called as actual parameters. So in actual parameters, we have call by value, call by reference, and call by name. Here call by value, directly variable 1 equal to 20, variable 2 equal to 20. Then call by reference, here you can see. So here actually the swap number function, here you can see it contains int pointer variable 1 comma int pointer variable 2. So now here we are calling swap function using reference, that is address, ampersand number 1 comma ampersand number 2. So ampersand is used to refer the address of that number 1 and number 2. So here passing values to a function copies the address of an argument. This is called by reference. Then whereas call by name, simply by using function name. So here void say hello. This is the function name. Its type parameter type is void. Then simply it prints hello world. So here function body. So here this is called by name. This is the example of parameter passing mechanisms. So then coming to the last concept, aliasing. So aliasing nothing but same name with more than 2 times. That means ambiguity. So one name having several meanings like that. When two names refer to the same location in memory, suppose x1, x2. So represent the same location in memory. So at that time, so we have to take the aliasing. There is an interesting consequence of call by reference parameter passing mechanism or its simulation, as in Java, where references to objects are passed by value. It is possible that two formal parameters can refer to the same location. Such variables are said to be aliases of one another, that is like duplication. As a result, any two variables which may appear to take their values from two distinct formal parameters can become aliases of each other. So this is the concept aliasing where you can use. So in same memory location, two different names uses the same memory location. So at that time, we will use the concept of aliasing. Whereas finally, the conclusion of the aliasing is any two variables which may appear to take their values from two distinct formal parameters, then they will become aliases of each other. So this is the concept of aliasing. Now let us see one example. So here we have taken call by reference parameters. For example, calculation of A1, then another one A2. Here you can see A is same. So A is aliased, same name, but with two different values A1 and A2. So A1 might point to same object as A2 because same memory location or same name is used. So this can be handled call by reference parameter. Whereas another one, int pointer p equal to ampersand x. So here address taken variables. Here pointer p refers to the same memory location. Here address taken as the variables. Then third case, without knowing specific value of I, the index of array, expressions involving subscripts here. Suppose here A of I, array with dimensionality I, might refer to any element of A. So these are all some of the examples of aliasing. Then let us move to summary of this lecture, what we covered till now. So the programming language basic concepts, what we covered, the static and dynamic distinction, environments and states, then static scope and block structures, then explicit access control, then dynamic scope, then parameter passing mechanisms like actual parameters, formal parameters, then aliasing. So next class, we'll come up with other interesting topics, lexical analysis. In this, you can refer the standard textbook AHO second edition, section 1.6, which gives the details about the topics what we covered.